so we'll just
No
do
worries.
screen share. I just want to make
Definitely
sure you
good.
can see my screen.
Yeah, we can see it. So the floor is yours. Thank you, Neil. You can proceed.
Okay. So hello and welcome everyone. So today I'll be talking about Git, and I've called this session Git in 30 minutes or less. The plan is we're going to go from nothing to a delivered deployable package all in less than 30 minutes, all using Git and Azure DevOps. So once we actually start the demo, I will actually start a timer to make sure I can demonstrate all of what I want to do in 30 minutes, and hopefully I will be able to. But my name is Nathan Clouse. I'm a technical architect with Invista. Invista is a Microsoft partner based in US and EMEA. So we focus on everything Microsoft, Dynamics 365, M365, Azure, and sort of everything related. I'm also a business applications MVP and have been for, I think, 3 years now. I run two blogs related to F&O. First is Atomic AX. That's my personal blog where I talk about mostly technical topics, but sometimes I stray into functional stuff as well. And then there's also dynamics.fo. So that's me, and actually Alex helps out as well, and several other MVPs. We have a process to keep track of and catalog all the new stuff that comes out with each release from Microsoft, because Microsoft doesn't always call that out very well. So if you go to dynamics.fo, we have a list of data entities, security changes, and features that are released by version at GA for every version from 10.0.17. So if you're interested in finding out more about specific features and when they released, you can look that up there. Additionally, I'm on Twitter at Nathan Clouse AX. So this is what we're going to talk about today. One of the feedbacks I've got, or one of the feedback I've gotten over the years, when I talk about Git, I focus a lot on the theory and how you do it. But for this session, I think I'm the last session, so this is going to be a little bit more informal. Rather than tell you about Git, I'm just going to show you Git, and we'll talk about everything along the way. So we're going to switch over to the demo. I'm going to need to unshare my screen and then reshare it. So one moment, please. Okay, so just
Hey,
need to
Nathan.
confirm that you can see Visual
Yeah,
Studio
I can see.
2019.
Yeah, I can see that.
Okay, so I'm actually going to start a timer on my phone to make sure I can actually do this in 30 minutes or less. So start stopwatch. Um, so what we're going to do is make a whole new project repo, configure everything, and then start using Git, making some commits, and delivering those via a package. So first, so we'll drag this over. So here is Azure DevOps. Here's a personal instance I've set up. I'm just going to go ahead and make a new project. We're going to call this, let's just call it Git123. The name sort of doesn't matter. What's the most important is our version control is set to Git here, and our work item process for this demo doesn't matter, but you can choose whichever you would like. So we're going to go ahead and wait for that to create. So now I've practiced this several times, so hopefully the only thing we're going to be waiting on is DevOps and Visual Studio. So next, I want to review just a few things so that I have pre-configured and pre-set up just to speed things up. So we're going to go into my artifacts here. I have a feed already set up that is at the organization level with all of my build artifacts. So those, watching me upload Git references just isn't very exciting. But I did want to call out a few things that I learned along the way. When you're using organization level feeds, you actually have to configure them. So in my own instance, I am a project collection admin. But because of how the build service works, you actually have to grant the build service for the project you're in the ability to see those organization feeds. Organization feeds exist one level higher um, than where you're actually, committing code. So just a real quick call out, we want to set our get123 build service to be a contributor or higher. We'll go ahead and save that. And just to make double sure, I'm going to go in here and go to permissions, go to my build administrators, and I'm going to add get123, the build service as a build administrator, just to make sure that it has access to all the assets that I need it to have access to. So from here, we've got our project. Now we just need to initialize our repo. So by default, it'll make a main branch. So we're just going to go ahead and click initialize. We do want a README. Right now, we don't want a .getignore file. I'll explain what a .getignore file is. Click the button. All right, I've got a repo. So now we can jump over to Visual Studio. So this is a dev VM that I have out in the cloud. One of the first things I'm going to need to do in order to make some of the magic work is break a few rules. So I will walk through that and add some disclaimers. But I want to say I've been doing this using this for 9 months or so. Haven't had any major issues. But we are going to have to make some changes to our web.config file. So that's on our service volume, AOS service, web root. No, I don't want to open a folder. I want to open a file. So open a file. So I'm going to search for web config in service volume, AOS service web root. And we have to make one change to this file. Right now, I have Visual Studio open as an admin. So that's what will allow me to actually make changes to this. So from here, I'm going to set this AOS metadata directory to a non-standard path. And this will be clear in a few steps why I'm doing this. So I'm going to set it to C/source. You can set it to whatever you'd like, but I'm just going to put my source controlled code somewhere else that is not the root for the package's local directory. I'm going to go ahead and save that. I do need to close out of Visual Studio because that file gets read when Visual Studio launches. So we're going to reopen Visual Studio. Then we're going to connect to our Git repo. So I'm going to go ahead and connect to a project. So we should have Git123 with our repo called Git123. And here I'm going to connect, set my path to be C/source. That's where this will clone the directory to. Already exists, so we need to make a new folder. Why does this exist already? Maybe from a previous test run. So go ahead and clone that. This is going to go ahead and actually recreate that directory. While it's cloning that, and we can take a look at what it did. So here's our README file that was automatically created, as well as some Visual Studio artifacts in a .vs directory. So we've now mapped it. So we actually have stuff in our source control. So if you look here, want to call it down here, the source directory is C/source, and I'm connected to the main branch for the repo I'm connected to. So far, so good. That change to the web.config file comes with a few warnings. So it's not officially sanctioned by Microsoft. It is a hack that just happens to exist and work. It comes with no warranty. This is, I'm trying to politely say, Microsoft doesn't want you to do this, but it works. And if this helps you adopt Git faster or easier, then my anticipation is that that will continue to work. Microsoft will be changing some of the ALM story in the future to be more Git friendly. So I anticipate things will improve rather than get worse, and that may actually be part of a planned future release. I don't know specifically, but we are breaking the rules a little bit, and I did want to call it out. If we were to apply an update to this machine, that value in our AOS, I'm sorry, the value that we changed in the web.config may change. We may have to put it back, but just want to call some of that stuff out. The next thing we need to do inside Visual Studio, because Git has a single source control directory, rather than with TFS, you can do multiple and sort of patch them together. We will need to change the default location of where Visual Studio puts our projects. So to fix that or change that, you go to Options, Projects and Solutions and Locations. Then from here, we'll just do C:/source/projects. Related to our build pipeline, which I'll talk about later, a lot of our values are predetermined by our build pipeline. You can set them to be whatever you'd like. You just have to adjust your pipeline to build pipeline to accommodate those different values. So I'm going to go ahead and click OK. If you're using Visual Studio 2017, your interface here will look a little bit different. I'm using 2019, which comes with a new Git Changes tab. But you can see on the right-hand side, there were some changes related to Visual Studio. So Visual Studio added some project settings and some SQL file extension of some sort. But we'll discuss that stuff a little bit later. But now I'm ready to actually go ahead and create a package. So while we're waiting for this, I have pre-selected some names for my packages. So I'm using specific values just to speed this up, but you can, everything that I'm showing you here today, all assets will be downloadable, and you can just find and replace strings with whatever strings you prefer. But we're going to create a model called test111. We're going to create a new package. Doesn't matter what I reference here, but I'll reference all the stuff you'd commonly use. And next, I don't want to create a project just yet, but I do want to make this model default for all new projects. So go ahead and click Next. So you can see here on the right-hand side, there's our descriptor directory, and added our descriptor file. Next, since we don't have a solution, I'll make one manually. So we're going to make a new project of type, finance operations. It doesn't really matter what I call it, but I do want to call out, it's going to use our new default for our projects directory, which will be inside of our source control directory. And then we'll just go ahead and create that project. So if we go back to our Git changes, you can see, me adding that project added a bunch of stuff. So here's our project file, our solution file, and some other various Visual Studio artifacts. But we're going to ignore that for right now. I'm just going to go ahead and add some X++ code. We're just going to add a class called class1. So this doesn't need to do anything other than be there and be valid X++ code. So we have a solution with a project, with a model and a package and a class inside of all of that. So if we go over here and look at our Git changes, there's a lot of stuff in here we really don't need. I only want to commit the Visual Studio level projects at a bare minimum, as well as our descriptor and any code I've added. So the next thing to do is we need to add something called a .gitignore file. This will let Git know what files on disk it can ignore from placing under source control, because we don't really need them. Visual Studio will keep them updated or build them on demand, so we don't need to commit them to source control. To do that, we're going to go to, let's see here, it's Git settings, Git repository settings, and of the ignore file, we're just going to go ahead and add one. click OK. So Visual Studio will use a very generic .gitignore file for Microsoft-based technologies to get rid of common assets and artifacts that Visual Studio just makes, and we really don't need to put under source control. So you can see just by adding that file, it cleaned up my list here. I don't have any of the was it SQLite file extension. There were a few others. But let's go ahead and look at this file. So this file uses various expressions to say what is and is not under source control. And if it's not under source control, I'm instructing Git to pretty much ignore it. One of the things that we'll need to do with a with X++ is it will generate some artifacts and place them in this test11 folder. So we're going to add some very F&O specific values in here. And this is again instructing what files and folders we want to have under source control and which ones we do not. This will be available at the end of the presentation for download. But this is just a very generic file that would ignore stuff we really don't need. So I'm going to go ahead and click Save. So now I'm going to go ahead and from here, just to sort of show that our .gitignore is working, I'm going to go to Extensions and Build Models. So I should have a model called Test 111. So I'm going to go ahead and build that. So if we were using something like TFS, we would expect to see a XPP metadata folder be created under our Test 111 folder in our source control. And our Git changes over here would reflect that if the folder is there. But it is there. I mean, we can potentially validate that. Yep. So here's our folder. It has stuff in it, but it's not showing up in source control. So our .gitignore file is doing its job because we don't want compiled source going into source control. We want just source going into source control. So next, I'm going to go ahead and stage all of my changes. Yes, I want to save my project. So now I'm going to go ahead and do my commit. So we'll just say initial commit for model test 111 and commit staged. So one of the things that's different about Git compared to TFS is this is only committed locally. So I haven't actually reached out to anywhere to persist this change set anywhere other than this VM. So this allows you to put together multiple change sets, sync up on a schedule that may be more just fit for how you want to work. It could be at the end of the day, could be at lunchtime where you do a final sync and go get lunch. But from here, what it's showing me is a diff window. So left is the beginning state and right is the ending state. But I'm just going to do a sync, so that'll sync up everything from this workspace to what's happened on the server. Since I'm the only one working in here, I anticipate no changes be pulled down. But now everything is synchronized. So now if I go back to my repo here, so I'll go ahead and refresh files. You can see I've got projects in here with my finance and operations project, my package, here's my model, here's my class, there's class 1. So far, so good. I did my first commit to Git and everything's going okay. Next, so at this point, I've got code, which is pretty good, right? What's something else you may potentially want to do with code once you've got it? So I'm not sure if I don't have chat open. I'm looking up a few assets I need to bring over that are pre-staged. But once we've got code, the next thing is we're going to need to build it. And related to that, I've got 3 assets that I have pre-configured related to my feed that I had pre-configured. And these are uh, my packages.config file, which just instructs my build pipeline where to find my NuGet packages in terms of version, and then NuGet.config is also part of that, tells us how to get those packages. And lastly, here's my build pipeline. My build pipeline will actually exist as a YAML file in source control. So each time I do anything with my source control, I have a predefined build pipeline that I can dynamically pick up, use, and execute whenever I want. So YAML is sort of another cool feature that we get. With Git, you can do something similar with TFS, but Git is sort of known for its YAML pipelines. So now I've got those 3 things. So I've got code, I've got a lot of build artifacts related to that. What's the last thing I need in order to actually create a build? So that will be a build project. So I'm just going to create a project called build. It'll exist in my projects folder. This project simply just needs to exist with a reference back to my test 111 package. And that's it. That's all it needs to do. It just simply needs to exist. So now if I go over to my Git changes, you can see I've added these 3 files along with a build project. So that sort of rounds out my entire set of artifacts I need in order to build or create a build pipeline. Build pipeline artifacts. I'm going to go ahead and commit all. Again, this only commits locally, so we're going to tell it to do a sync with the server. Okay, so everything should be good there. So we'll flip back to DevOps and look at my repo. So you can see I've got my pipeline, my config packages, and all that good stuff in here. It looks like we have a question. Says question, if we're going to use Git as source control, can we possibly use Git actions and have automatic deployments in our environments? I guess I'm going to save that question for later. I actually have a series of slides to talk about stuff like that. I guess I'll hold that thought and we'll talk about it. So now that I've got all of my build artifacts set up in here, I'm going to go ahead and build a pipeline. So if you've done this in TFS, you can either import one or build it from scratch. Using Git with YAML, all I'm doing is saying I will go back one step. I want to make a pipeline. I'm going to have that pipeline be backed by Azure Repos Git. Here is my one repo that exists in my project. It found my YAML file based on its name. And this is one that I just pulled from Microsoft. So I have a link to where to get this at the end of the presentation. We'll go ahead and save that. I do not want to run it yet. So now we've got code. We've got a way to build that code. There's one more step. And that is making it so that if we have any potential bad actors or people that just don't fully understand Git, we set up a few sort of fences just to make sure they're not accidentally doing something and maybe not fully appreciate their actions. So we'll go into settings and repositories and pick our one repository. A lot of these options are on by default, and we just want to leave them on. Specifically, we want to get into our main branch here. So some of the features that we want to turn on are we do want to require a minimum number of reviewers. So part of one of the really cool things that comes with Git is the sort of ability to automatically have code reviews just built into the process. Normally, you'd want to have this be 2. For this demo, I'm going to have to set it to 1, and I'm going to be allowed to approve my own changes. Next, we want to check for work items and have that be required. So we're not just going to accept any code that's not tied to a work item. You have to have a work item in order to commit. And lastly, we want to limit our merge types. So related to a pull request, there's a few different flavors of types of commits. When you're committing code, like I just did, it's really easy. That's just commit. There's nothing special about it. But when you're looking at pull requests have merge types that are associated with them. So what we're saying on this branch is we're only going to accept commits with merge types, and these are allowed merge types. What this is doing is making it so that we cannot commit directly to main anymore. So we have to do it through. We can only make changes to main through pull requests, and we can only do that related to work items. And lastly, we're going to add in some build validation just to ensure that at a minimum, a lot of our stuff will compile, and then we can add specialized pipelines in later. So now that we've got all of our different processes set up and pipelines, we're going to actually go over here and we're going to walk through a very simple change ticket. So we'll go to, I'm just going to make a new work item called task. This is going to be just very generic, so we'll just say fix the thing. I'm going to assign it to myself. For the sake of a demo, I'm just going to change code. I don't really need an actual change set. But now that I've got a task, I can create a new branch that will automatically be associated with my task. So we'll call this branch fix the thing. It's going to be based on repo get 123 and branch main. So I'll go ahead and create branch. So next, I'm going to duplicate this tab. We'll go to our pipelines. So you can see we've got a queued pipeline that's waiting to execute. And what it came from is an individual continuous integration execution for the creation of this branch called fix the thing. So what's happening is I made a work item. I created a branch for that work item, and I presumably am going to assign that work item for someone to work on. Continuous integration is taking that branch creation and saying, all right, I've got source code here. I'm going to run it through a very simple build pipeline just to validate that it compiles. What that's doing is if you're handing off this task to another developer, they're starting with a branch that you know compiles. So if it compiles at the beginning and doesn't compile at the end, they did something they need to address. So it's a really simple check just to make sure that things are going executing as you're expecting. Related to this, while we're waiting for this to build, every time that you do a commit of any sort to any different branch, we've configured it so that it will do at a minimum, validate that all code will execute. So what I'm going to do next is I'm going to do a sync because so now we'll pretend that build has executed successfully. It's going to take about 3 minutes to run, and we're running a little bit low on time. But I did a sync, and that resynced Visual Studio to Git. So now from here, I'm just going to select my branch, go to remote, and now I've got the option for the branch called fix the thing. So it's letting me know that this executed, this background task, but it's complete because my status here is ready. So I'll go ahead and open a project or solution. I'll open this one again. So you can see I've got class 1 here. I'm just going to go ahead and add another class called class 2, just so that we can watch our classes move around. So go ahead and hit save on everything. You can see here's our changes. I'm going to go ahead. Those are or stage all those. Then if we want to look at what changes happened, so here's we added a new node and our project definition for class 2. And then here is our class 2. So I'll just say fixed the thing, commit staged. Go here, do a full sync to push that up to the cloud. Now this commit action will have triggered another build pipeline execution. So our first build pipeline from the creation of the branch looks like it's still executing. It's in the build step. No errors so far, so that's pretty good. Yep, it's actually building right now. But you can see we validated, we are starting with something that compiles. We did a commit. We're going to make sure that commit compiles. And there's a few other things that we need to do. So if we go back to my task, you can see here, I'll expand this. So once our commit build pipeline has successfully executed, we should see a commit here. But next, I'm going to create a pull request. So this is what actually move our code from the fix the thing branch into the main branch. You can see it's connected to our work item down here, 207 fix the thing. So we'll go ahead and create that. So right now, we've got some automated checks that must pass before we can even do anything with this pull request. I cannot approve this at this stage because I've mandated that a build must successfully execute before this can be approved. So we will have to wait for that to run. But inside of our pull request, you can see here are the files that changed. Here's the update. Here's the commit. The one commit related to this. And then if we hop into that commit, we can see that the same sort of diff changes that we would expect to see here. So now let's take a look at our pipelines, see what's going on. So this one, because our branch create is successful. Our commit from adding class 2 is still running. And then our pull request pull request pipeline execution is in the queue. So really all that's left is to wait for these to finish running. And then if we go back to our pull request, so we'll take a look at this. So it's still got, we're still waiting on that build. So we'll come back to this in just a little bit so I can finish sort of showing the demo. But there's one more build execution that we'll see in all this once we accept our pull request. I will just move this over here and we'll go through the slides. So one of the challenges that we've had with package management when it comes to Git is the Git is designed to be just a single folder, where TFS you can mix and match folders. So TFS, you can have one for your package's local directory and another repo for your projects, and they can exist in different places. Git is a little bit different than that. So Git really likes to just have one central folder that all artifacts are in. From there, that sort of limits what we can do. You can have one package inside of your package's local directory where you put everything in it, or you can put all of package's local directory under source control with Git, using some tricks that I've outlined in an article. And then you just tell Git to ignore everything that Microsoft ships that is part of the package's local directory. But what I showed you today is sort of a hybrid. It's a best of both worlds. where you get a really simple setup. We had to make one change to our web config, and then uh, we're able to just use Git as we would expect. Um, and a lot of the negatives around having to manage some of the complexity around packages, local directory just aren't there. Um, and really, why I really like to talk about Git and say this is a good fit for everyone is when you look at the life cycle of a branch. A lot of our work tends to be where a senior or tech lead developer um, will create a work item, design the solution, uh, create the branch, assign the work item to a dev. The dev will just do the work, test it, and create a pull request to signal, hey, hey, I've done the work that you've asked. Um, so it's really collaborative in that you can have one team designing and another team developing, and there's a lot of communication in between. It really makes a lot of sense. And specifically when you're looking at something like this down here with feature A, B, and C, you can see that our commits are represented by these blue dots. We could potentially have one developer flipping between different features and committing to different places. So if you're familiar with it's sort of how TFS worked, that wasn't an easy thing to do because typically how I see TFS being set up is all code went to one place. So then you have to start determining which change sets you have to bring with, and sometimes some change sets from one feature include parts of a different feature. So there's just a lot of moving pieces you have to manage because in TFS typically all code goes to one branch. Not so with Git. Git is designed to be um, you make a workspace for what whatever it is you're working on. You do the work to create a pull request. Everything builds and tests and is reviewed and approved as you would expect. Then that branch goes away, and you can make a new one if you need to. Um, so where TFS is you create your branches and they exist there forever. Git is a whole lot more create a workspace for whatever it is you need to work on, execute it, and then you're done. And then you sort of throw that branch away and move on to the next thing. Um, again, with Visual Studio, so it's 2017 and 2019. Hopefully, everyone is using those versions. You can do all of your work just inside Visual Studio. So there are a lot of Azure DevOps plugins that just ship with Visual Studio. So you can get your work, get your branches, get everything you need to do, and deliver. And a lot of the communication is sort of automatically happening behind the scenes. So if you want to be a developer that doesn't have to talk to anyone, you can just certainly do that if you'd like. And Git helps support that because a lot of the communication for issues, for signaling that you're done with work or you completed something, it's just built into the process. Next, we had a question about GitHub Actions. So yes, you can use GitHub. I'm specifically showing using Git on Azure DevOps because of some of the builds pipelines. GitHub would also work, or really like any Git-backed repository provider will work. Um, but there's a few sort of gotchas with that. Right now, it's not documented very well, nor is it supported. Um, Use of Git in general for F&O isn't supported in the most generic sense, whether it's DevOps or GitHub or anything else. That shouldn't scare you. That just means that Microsoft won't provide support for that version control system for X++. That doesn't mean that if you develop a feature using Git and deploy it to production, Microsoft's going to find out and say, oh, well, you used Git, so your entire code base is suspect and we're not going to support you. That is not the case. But when looking at GitHub or anything else, stuff with GitHub Actions, I'm sure we could figure something out, but the build story there is not really complete. There's still a lot of things to figure out from the community. Similar with the release story, moving let's say a successful build into a UAT environment, for instance. Still not really sure how that would work using GitHub. Um, and what we've seen, this is probably the most controversial thing I'll say, is historically DevOps has been for enterprises only, where GitHub is largely community. We're going to see that story change quite a bit, where GitHub is going to be for indie devs that are developing, whatever they would like to develop, and it's just them, up to large organizations with very large teams in the enterprise space. And we'll have tooling available on GitHub for all parties that are interested. Um, Next, I really want to draw this out. Actually, let's check back in with our pull request here. Okay, so I think I've gone over my 30 minutes, which is unfortunate, but you can see here for my pull request, I had 2 checks. I have to have a successful build. So at a minimum, the code that I committed will build. It is linked to a work item. Right now, I do need to have an approver. So I'm going to approve this. So I've got my 1 approver. I'm allowed to approve my own work. I have no merge conflicts. I have a successful build. And it is linked to a work item. I'm going to go ahead and complete this. To draw this back to stuff we talked about earlier, here are my allowed merge types. So this means I cannot commit to main directly. I have to use a merge. That merge has to come through a pull request. So I've put some protections on main just to make sure that we're not going to accept code that won't compile and code that is not linked to a work item. I'm going to go ahead and complete the merge. So automatically complete associated work items after merging, and then delete this branch after we're done. So based on our build pipeline and all activity we've done so far, everything looks great. We've passed all of our checks, all of our rules. I'm going to go ahead and hit complete merge. Some automation is going to kick off behind the scenes. So it is merging the pull request. So automatically merged it into main. My work item for this, let's find my work item, is now closed. If I look at my activity and my links, you can see that I had a commit. I completed this pull request. Here's the pull request. This lets you know that there was a branch called fix the thing that is merged into main. It is now gone. And if we look at our files, you can see we're looking at main right now. There is no other branch here called fix the thing. It is now gone. And we'll take a look at our classes. And here's class 1 and 2 that we added. And one final thing. If we go to our pipeline, we're doing another build after we've accepted our pull request to confirm this consistency of main. So just to walk through this, we created a branch, made sure it built. We did a commit, made sure it built. We proposed a pull request. It staged that pull request, merged my code, did a build, that passed that check. Now it actually did the pull request into main, and now it's building again. So you can just see we have a ton of verification that our code will at least build. And with build pipelines, you can include whatever else you'd like in there with automated testing to ensure that the state of your repo or repos is good, hopefully 100% of the time. But we've got tooling built into that whole process. And this just happens behind the scenes. I don't even, as a developer, I don't need to know any of this is happening, except that when my build pipelines fail, I'm going to get a work items automatically created and assigned back to me. Say build pipeline failed. Here's your error. Here's your task. Here's your branch. Fix it. And potentially that would alert more senior devs as well that there is an issue. But a lot of utility, there just to ensure that our code will always build and always work. So we've really talked through pull requests, but again, just another way to ensure that our code quality is consistent, high, and is being reviewed. That doesn't mean that some code reviews won't look like this, where you're really just saying what's going on here. But pull request plus our YAML pipeline. YAML is just another markup language. There's nothing really special about it, other than it allows you to place your build pipelines in your source control. So wherever your source code goes, you've got an automatic pipeline for it. We have a question here. Is it a complex thing to switch from using TFS to Git? Um, no, I've actually, let me scroll down to the end. Um, there's a list of resources here. I actually have an article on talking about how to do that. It is just as a call out, you are creating a whole new repo. All history associated with TFS stays over there. You're basically making sort of think of it as like making a new project. You can have Git repos and TFS repos inside of Azure DevOps exist next to one another if you'd like. Um, but you just have to make sure, which one it is that you're working with. Um, but yeah, you can switch from TFS to Git, and conversely, you can go the other way as well. They are independent source control systems that I don't know. They don't really care about how stuff gets added to them. They just work the way that they're designed to work, and that's it. Um, and lastly, I just want to call out. Um, there's a lot of good documentation out there that relates to branching and how you can do features inside Git. There are much more knowledgeable people out there that have YouTube videos, but I did want to scroll through, a few potential options around how you can do your branches. This is a very complicated and similarly with this, but you can see some of our feature branches down here go away. So you have to think about sort of make the mind shift to my branches don't have to exist forever. What does my branching strategy look like in that scenario? Um, so lastly, let's flip back to our pipelines. So you can see our build pipeline executing successfully. So our main branch is now in a known good state from a known good state all the way through development of a new feature. Um, so I'll open it up for any questions.
Yeah, I think Sanchez have some couple of questions I can see at the bottommost.
Yep,
And
I believe I answered those.
okay, that's great. Other
But I did
than
want to
that,
throw,
already answer. Perfect. Yep.
want to have this slide up. So everything I've talked about today, we've got various sources for how to find that stuff or how to integrate those assets, or just more talk about ALM. I'll call Adria's, I believe it's called the Get ALM Bible. That has tons of information. It discusses a lot of the different topics from a mechanical point of view. Um, So if you're unsure of like, what is a feed? How do I get assets there? What are NuGet packages? Adria's link right here uh, is good. And lastly, just as a call out, the build pipeline that I showed off today, I just pulled for Microsoft. It's downloadable at this link as well. So here's all my contact info. Again, if you have any questions, feel free to reach out. Um, I would sort of always love talking about Git, so feel free to reach out with any questions or if you need anything. Juan had a question. Is the recording going to be shared?
Yeah, it will be. Yeah, so I was just mentioning it out here. Yes, all recordings will be available on the Pakistan User Group's official channel. Maybe after the sessions ends by next week, we will have all the recordings uploaded.
All right, sounds good. Um, so that was the end of the presentation. I believe I'm the last presentation, so I'll hand it back to Pakistan UG support. So thank you, everyone.
Thank you. Thank you again, Nathan, for your time today. Appreciate giving us time over a working day. It was a really insightful session, especially when it comes to how do you think manages things in the GitHub. I appreciate your time and thank you everyone for your presence today. With this, we are going towards the end of our today's session. We will be resuming again the digital sessions on Sunday and looking forward for you guys who are planning to attend the event in hybrid mode on Sunday, while we will have a face-to-face session here in Pakistan on tomorrow as well. So thank you everyone and enjoy your rest of the evening and good day. Bye.
Thank you.
Thank you all. Bye.
Thank you. Bye.